Chapter 4.1 Solving System of Linear Equations by Graphing. A system of linear equations is a set of two or more linear equations in the same variables. For example, y equals x plus 1, y equals 2x minus 7 are called system of equation because if you have more than one equation, they are called system of equations. A solution of a system of linear equations in two variables is an ordered pair that is a solution of each equation in the system. The solution of system of linear equations is the point of intersection of the graphs of the equations. Key ideas: solving a system of linear equation by graphing. Step number 1, graph each equation in the same coordinate plane. So we're going to graph both of them into same coordinate plane. Step number 2 is find the point of intersection, the ordered pair. So wherever the two lines will cross, we're going to take that point and it's called point of intersection. Step number 3, check the points from step 2 by substituting for x and y in each equation of the original system. So you're going to use the coordinate point and plug it in into the equation one by one to check for solution. Example number 1, solving a system of linear equations by graphing. So you have two equations given. The first equation is y equals 2x plus 5. You find the slope of this one and the y-intercept and graph. So the slope of this equation is 2 and y-intercept is 5. You're going to plot the y-intercept 1, 2, 3, 4, 5 and apply the slope. So slope is up 2 over 1. Since it's a positive slope, it means it's going to rise from left to right. So you get few points, connect them, and you're going to get a line graph. Now the second equation is y equals negative 4x minus 1, where negative 4 is going to be your slope and y-intercept is negative 1. I'm going to use red color so that I can differentiate between two lines. Starting from negative 1 here, you're going to go down 4 over 1 and up 4 over 1 onto the negative side, up 4 over 1. Remember, this is going to be a negative slope, so it's going to fall from left to right, and the two lines where they intersect is this point right here, and that point is negative 1 comma 3. So the points are negative 1 comma 3. Now you're going to check for solutions. So you're going to take the lines one by one. So the second line is negative 4x minus 1, and then the first line is y equals 2x plus 5. You're going to use y as 3 and x as negative 1 and see they are equal to each other or not. So here you get 3 equal 3, which is true. So it means it's a solution for equation 1. Now we are going to use for the second line and plug y as 3 and x as negative 1 to see if the two sides are equal. So 3 equals 3, the two sides are equal. It means the coordinate negative 1 comma 3 is a solution of both the equations. Now we are going to try the problem number 1 and 2. For number 1, you have a slope of the first equation as 1 and the y-intercept is negative 1. When you graph it, you start from negative 1, which is the y-intercept, and then for slope you go up 1 over 1, up 1 over 1, and you extend the line from both sides. Remember, this is going to be a positive slope, so it's a line that rises from left to right. Second equation is y equals negative x plus 3, where slope is negative 1 and y-intercept is 3. So you start from 3 here, go down 1 over 1, down 1 over 1. Since it's a negative slope, so it's going to fall from left to right. You just extend the line a little bit more on each side and connect the points, you get the line graph. Now the intersection point for these two lines is this one, which is 1 comma, or it's going to be 2 comma 1. So the intersection point is 2 comma 1. Now we're going to check for both the equation. For equation number 1, you have y equals x minus 1, where x is 2 and y is 1. So you plug these 2 points. So x is 2, y is 1. And then see if they are equal to each other. So 1 equals 1, which is true. And then the second equation we have is y equals negative x plus 3, where y is 1 and x is negative 2. So you got 1 equals 1, which is true. So which means that 2 comma 1 is a solution of both the equations. For question number 2, the first equation is y equals 5x plus 1. So the slope is 5 and the y-intercept is 1. So you start from 1 and the slope is 5. So it means you go up 5 over 1. So 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. Connect the points and you get the line graph. So this is the line graph you got, and remember this is a positive slope, so it's going to rise from left to right. The second equation for this is y equals x minus 3, where the slope is 1 and y-intercept is negative 3. So you start from negative 3 and go up 1 over 1 and get the points and connect these points to get the line graph. So this line graph is cutting the other line graph at this point, and this is going to be negative 1 comma negative 4. So the point of intersection is negative 1 comma negative 4. You use the first equation to check if this coordinate is going to be a solution or not. You plug it in x value as negative 1 and negative 4 for y value, and then solve to see the two sides equal or not. So here you get negative 5 plus 1, which is negative 4. So negative 4 and negative 4 are equal to each other, so this is true. For the second equation, you're using y equals x minus 3 and use y value as negative 4 and x value is negative 1. Negative 4 equals negative 1 minus 3, that is negative 4. Negative 4 equals negative 4 is true, so it means that this coordinate negative 1 comma negative 4 is a solution of these two equations or a system of equations. For question number 3, you're going to have a slope. For the first equation is 1 and the y-intercept is 0. So starting from 0, you go up 1 over 1 because it's a positive slope. So this is going to be a rising line from left to right. Connect all these points, you're going to get the line graph starting from 0 up 1 over 1. Next line is y equals 2x plus 1, where the slope is 2 and y-intercept is 1. So you're going to start from 1 and then the slope is up 2 over 1, up 2 over 1, and on the same time on the other side up 2 over 1 or down 2 over 1, down 2 over 1. Connect these points, you're going to get the line graph that are intersecting at this point, which is negative 1 comma negative 1. So the point of intersection is negative 1 comma negative 1. Now you're going to check for solution. So your first equation is y equals x. So you're going to put -1 for y and -1 for x, which is true. For the second equation, you're going to use y equals 2x plus 1, y as -1, x as -1. You got -1 equals -2 plus 1, which is equal to -1. So it is true. It means the coordinate -1 comma -1 is a solution of the system of linear equations. For question number 4, you have the first equation as y equals -5x plus 14, where the slope is -5 and then y-intercept is 14. I made this number line so that you have by 2, because this is 14 does not going to be fit on this graph. So I took the difference of each section by 2. So 2, 4, 6, 8, 10, 12, and 14. So this is going to be 14. Slope is -5, so it's going to go down 4 and 5 in the center here, because 5 goes, so this is 2, this is 2, that's 4, and then half is going to make a 1. So down 5 over 1, down 5 over 1, down 5 over 1, and then down 5 over 1. Where is going to cut at this point. Now for the next one, you have a slope as 1 and then y-intercept -10. Starting from -10, you go up 1 over 1, which is going to be at the half, because we take this section as 2. It means 1 is in between of every section. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So that's going to be this point of intersection. And this point is 4, -6. Now you're going to check for the solution. So the first equation, y equals -5x plus 14, y you plug it as -6, x as 4, and you're going to get -6 equals -20 plus 14. So that's going to be -6 equals -6, which is true. Next equation is y equals x minus 10. You're going to plug y as -6, x as 4, and see if the two sides are equal or not. So the two sides for both equations come out as true. So it means that 4, -6, this point is a solution of system of linear equation y equals -5x plus 14 and y equals x minus 10.